Hello, everyone, and this is Seamus McGovern. I'm the founder of ODSC, the Open Data Science Conference, and I'd like to welcome everyone and thank you once again for taking time out of your busy day. Now, before I introduce today's presenter, I would like to say just a few quick words about ODSC. Some of you know us and some of you don't. If you're interested in this kind of content, please check out our blog site at opendatascience.com. You'll find lots of great content around data science and AI there. And just to explain a few things, as you may know, we run conferences around the world, including Boston, San Francisco, London, and Asia. And really, you know, our core focus on our events and our conferences is that we make sure that the content itself is of the very highest caliber and that our speakers are very knowledgeable. So we do pride ourselves in that. And as you can see on this slide here, we have an event coming up relatively soon. Our next big conference is at ODSC East right here in Boston, where we're speaking from, and that runs May 1st to 4th. We've expanded that from a 3-day conference actually to a 4-day conference. First 2 days are going to be around training and workshops, and then the last 2 days will be keynotes, trainings, and talks. And I think we're going to have an astounding 200 sessions across those 4 days. In addition to that, for those of you who are more on the business side rather than the technical side, we also run this event, which is near and dear to my heart, called Accelerate AI. And that really is about teaching business professionals the latest skills in data science and AI in a non-technical way. Like this webinar where we have coming up now on user segmentation, that's a really important thing to understand for anyone on the business side in marketing, in sales, and all that good stuff. And okay, so without further ado, I want to introduce our speaker. And before I do that, I just want to tell you the format. So the format is we're going to do a 30-minute talk here. It will be recorded so you can review at your leisure after. And then once that talk is over, we'll go into a Q&A. So you'll notice on the right of your screens, there's a chat window there. So you can post questions from that, and the presenter will pick the questions to answer there. So as you can see, our speaker today is Ruben Kogel, and Ruben is the Director of Data Science at VSCO. Prior to VSCO, Ruben was leading the content analytics at Udemy. And as you guys know, it's an online education platform, and his interests span statistics, machine learning, economics, and of course, photography. So with that, I would like to hand it over to Ruben.
Thank you, Seamus. Thank you for the introduction. I'm really glad to have the opportunity to be able to give this seminar. Before getting started, just want to mention that so I'm the Director of Data Science at the VSCO, but mainly I'm really focused on analytics, data analytics. That is all the data that is being used to measure the success of the business or to help really anyone make business decision at VSCO. And so the topic of my talk, my webinar, is about database user segmentation and how we can use certain tool or techniques to come up with segments, but also with particular attention to kind of tricks and idiosyncrasies that can lead to problematic results when we apply straight-up textbook segmentation techniques. So let's get started. So what is VSCO? VSCO basically is a community and tools for creators. At its heart, it is a mobile app available on iPhone and Android. We have about 45 million monthly audience across both web and mobile, 12 billion images being served monthly, and about 70% of our daily audience actually create on VSCO. And I've added on this slide 2 screenshots from the app. One shows the editing mode. So VSCO gives you over 100 different filters that are widely considered like the best filters you can find, very subtle, people love it, and you can do like all your editing there. And then you can also have your own profile, post in the community, discover other photographers, etc. So that's what VSCO is about. Now, before also diving into the segmentation portion, I'm sure some of you might be interested to know what stack we use at VSCO, especially the stack for data science. So I just want to spend a few minutes describing how we collect the data, where the data comes from, and how we analyze it. So, first step is the data that we collect is being produced by a lot of different pieces. So first of all, we have our app. So the app is available on iOS and Android, so that's what we call the client. But there's also a website, so that's the VSCO web. We also get information from the App Store, from third-party vendors like App Annie, and also from our internal production database. Example of that is like who is a member of VSCOX, or when people join, and etc. There's all information stored in our internal production database. So we have all this information being produced in different places. The next step is to collect the information and make it visible to other people. So that's where things like Mixpanel comes in. Mixpanel, for those who don't know, is a mobile and actually web analytics suite that basically takes all of your data on the one hand, ingest it, clean it up, put it in a very high performance storage, and then make it available for you to dive into and discover. So it's a like all-in-one solution that is essentially used at VSCO for product analytics. So any product manager, designer, or engineer that wants to know how a particular feature is doing will go through Mixpanel for that. This is like an overview of the data science stack at VSCO. So on the left, we have all the producers, the data producers, whether it's the iOS, Android client, VSCO web, App Store, third-party production database. From there, we ingest the data. We have our own internal SDK called Cantor, and then we push that data into Kafka that eventually gets stored into S3 bucket in Parquet file, and S3 bucket is really our source of truth. Some of it gets extracted and pushed into Amazon Redshift, AWS Redshift, and from there we can do deep analysis with a SQL client. We also plug in Periscope for dashboarding. So why segment? There are different type of uses for segmentation. One is marketing design. So the marketing and design function, they need to do segmentation to answer a couple different questions. They might want to know how to position the product in the market. They might want to know how to message different potential target audience for the product. They also need to know what are people using the product for, so that they can make it as intuitive as possible. On the other hand, there's growth and business operations that are also interested in doing segmentation, but their interests are different. They typically want to understand how users use the app, who are the most engaged users, what are their characteristics, and how can we grow the different segments of users across the audience. And an important distinction also is the result of segmentation for marketing and design is typically building personas that represent potential or actual users, and that are helping visualize like who do we market for, and what kind of product do we build. But for growth and biz ops, the outcome is typically a database segmentation that represents how people are actually using the app. So already we can see like a difference. On the one hand, we build personas essentially based on interviews with like either potential audience or actual audience, and on the other hand, for growth biz ops, we build segments based on data. So now let's talk about segmentation. Probably some of you have learned about k-means as a way to create cluster, and maybe you've learned like a canonical example in a textbook. Let's say that we wanted to organize or segment our users across two different dimensions. Here is usage frequency of a car, and on the other axis is how many miles are being driven. And when you do this kind of segmentation, it's like very clear that people get segmented into 4 different buckets. You have people with very high frequency and low mile driven, so that might be commuters. You have people who high usage frequency and a lot of miles, so those might be taxi drivers. A lot of miles but low usage frequency might be weekenders, and then people at the bottom left, the left corner, people who don't really own a car. But in reality, that's not what the data looks like, and that's never that easy. So in reality, what you see is this. Let's say that we looked at editing usage on VSCO, or number of sessions per week, or how many images are being published. All of those, the connection between all of those distribution is they're all exponential, right? You always have more people editing 0 image than 1 image and 2 image, etc. Same thing for number of sessions. You have more people having 1 session than 2 sessions and 3 sessions, etc. And when you have this type of distribution, which is the common distribution of any activity and most business metrics, really, how do you decide where the line falls? It's impossible. It's totally arbitrary just by looking at these curves and deciding, like, to the left is going to be a low usage and to the right high usage. Not only that, but also you might have more than 2 or 3 dimensions. Oftentimes you have like 10 or 15 dimensions you want to consider. So it's not at all straightforward how different clusters or how different segments are generated from the data just by looking at those dimensions. And this is why we need an automated system. This is why we need an algorithm to actually tease apart the different clusters and do it for us. So the step 1 in doing user segmentation is to choose the right inputs. I think this is, for those of you who are familiar with data science, this is probably one of the most repeated trope across data science, garbage in, garbage out. You won't have a good model unless you have really good inputs. And really getting the good inputs is probably the single most important step in any data modeling or data analysis project. So the problem with k-means is what k-means does is it finds the dimensions with the most separation between the groups and use that information to form clusters. So going back to our data that I showed earlier, if we find that across the 3 dimensions that I showed, which were editing usage, number of sessions, and publishing usage, number of image published, if we find that one of them is able to explain the most differences across our user base, that is being selected first by the k-means, and then it does it with all other dimensions until it finds the clusters that are trying to explain as much variability as possible given a predefined number of clusters. The question here is, we can add more and more dimension to our k-means analysis, but does it add more information? If I were to add number of image published and number of images uploaded and number of images exported, those are all actions that are extremely correlated. And so, yes, adding more and more dimensions will increase the explanation, or like we increase the coverage of my clustering, but it doesn't really add much information. And so I should really restrict myself to the dimensions that are most different from each other, and that together can explain most of the variation I see. So that relates to the second point around eliminating unnecessary input variables. And so for that, really the key is to use intuition as well as data exploration. Then the next piece is we want to segment only the things that matter. If in this case here, we want to segment users based on their behaviors and trying to understand whether they're like, super users or casual users, and what part of the app they're using, we don't want that information to be deformed or to be influenced by other factors like how old the person, how long the person has been on the platform, or how many total photos or total editing that person has done over the last 3 or 4 years. Because once we start injecting those factors, it distracts from like the main goal, which is to segment on actual behavior as of today, not behavior as of last year or 2 years ago. Finally, this is an iterative process. Really, the key here is to generate some clusters, look at them, see whether they make sense, and then redo it, prune some dimensions until we find clusters that make sense and that it can explain a good portion of the variability in the data. So that's kind of like the general first step. The second step is, my favorite one is log transform all the things. It's very, I think it's very important to use log transform as necessary, and in many cases, those cases call for log transformation. So why is that? So let's go back to our prior set of examples. We talked about, let's say, like number of sessions per person per week. The difference between someone doing, if you use a linear scale, you basically are saying that the difference between, so here I'm talking about editing, but the difference between 1 and 2 editing photos counts the same as the difference between 101 and 102 edits. But intuitively, you know that that's not true. There's a much bigger gap, psychological gap, and also behavioral gap between people who edit 1 and 2 photos and people who edit 100 and 102 photos. In fact, the people who edit 101 or 102 photos, they're, for all matter purposes, they are essentially the same. However, there's a difference between 0, 1, and 2. So that's what the log transform does. It really blows up the scale at the low end, and it makes the gap between 1, 2, 3 edits much larger than the gap between 100, 101, 102. So whenever you have this kind of like very steep exponential distribution, and whenever you can reason that doing 1 and 2 actions is very different from going from 101 to 102, you want to use a log transformation. Step 3 is using the right number of clusters. So I alluded it earlier, but there is a trade-off between creating more and more clusters that can explain more and more the variability in the user base, and also being sparse. And the reason for that is it's a general rule of data modeling that we want to be as sparse as possible and yet explain as much as possible. So here, what that means is we want to use the smallest number of clusters or segments that can explain most of the variability. So I have a little nifty plot here that basically show what I got when I was running with different number of clusters. So you start with like 1 cluster. 1 cluster means essentially everybody's in one group, and you can see that it explains only, it explains like 0% of the variance. But as soon as you introduce a second clusters, now you can group people into 2 segments. You've explained about 45% of the variance, et cetera, et cetera. And at some point, going from 4 to 5 to 6 doesn't add much in terms of explaining the variance. And so really here we should stop around 4 or 5. Now the next step is once we have those clusters, it's very important as a data analyst to be able to deliver the insights in an intuitive way that other people who are non-technical can understand. And that's really, again, like one of the crucial part of data science is, it's great to have great models and doing like incredibly complex analysis, but if you're not able to communicate the insights and able to help other people at the company understand what you've done and what it means, then it's really worth nothing. So on the left is an example of the output from that k-means analysis, that clustering analysis that I run on the data. This is the output from R, and this is like illegible. I can barely read it. I bet even like a seasoned data analyst cannot understand what's going on. It's incredibly complex. On the right is the data as I published it and shared it with the rest of the company. And now instead of having cluster number 1, 2, 3, 4, 5, etc., and 6, I give them names based on the characteristics. So now we have the one and done, the casual editors, the super editors, the community editors, the feed explorers, and the super users. And for each of those segments, instead of giving the center, which is like the average behavior across different dimensions, I'm actually giving a range that corresponds to like the 80% range of people. So for example, the super editor tend to edit between 13 and 41 photos per month. They publish 0 and they go to the feed 0 times a month. Compare that to the super users who tend to edit between 10 and 42 photos a month, but they also publish between 7 and 22 photos to our community, and they go to the feed 17 to 27 times in that month. So that gives us a much more concrete view of what's happening, and those are now segments that people in product, people in biz ops and growth can take and understand and run with it. The next step is once we have those segments and we have defined boundaries, actually we need to use programmatic rules in order to track them over time. Because if we are rerunning the segment, the k-means or the clustering analysis every month on the entire audience, what we end up with is we end up with segments that are different, basically clusters that look different, because the data is never the same, and the k-means is just like an algorithm that will optimize and find like the best segments given the data. But if you do that, someone that might be classified a super editor in one period might be classified a casual editor the next period with the exact same behavior. So in practice, if you are going to start tracking those segments over time, you do not want to redo the clustering analysis every time. You don't want to rerun the algorithm. What you want to do is instead you want to infer the boundaries from the initial analysis, and then use these boundaries to create rules that will automatically classify people in different segments. So if we go back to the examples that I showed earlier, here we might say, someone who has at least 17 sessions in the feed and has some editing and some publishing will be classified as super user. Next, if that person has, between 4 and 17 sessions in the feed, but less than 4 edits and less than 4 publish, that person will be classified as feed explorer, et cetera, et cetera. And so that's how you actually generate those rules and those segments in practice when you want to track them over time. So I spoke about tracking things over time, and I think that's another important insight here, is that oftentimes bridging the gap between insights and actionable insights is building dashboards and building visualization that will help people refresh the insights and will help people track how the things go over time. So here is an example of a dashboard that I built to track the different segments. So on the left, we have the composition of our audience per month with the different segments. So here you'll notice that there are actually 7 segments, and that's because there's like unclassified people. And then for each segment, what would be interesting is to understand what's the source of that segment. How are people transitioning from one segment to the next in each month? And that's the graph on the right. So that's a blow up of the green segment, and you can see that most of the green people were actually green in the previous period, and with a little bit of blue and some orange. So to summarize, we learned that marketers, designers, and analysts, they all use different segmentation methods, but they are really complementary approaches. The database segmentation is useful to track usage, and it should be based on behavioral data only. We don't want to add geography, demographics to it, otherwise it'll skew the segments. And we also learned that most usage data is exponential, and so most of the time we need to log transform it to get better output. and we need to use machine learning algorithms in order to identify the cluster boundaries for us, because we can't just read it from the data. So the six steps to doing clustering analysis: one is choose the right inputs, two is log transform almost everything, three is choose a number of clusters that make sense to have both explanatory power as well as sparseness, four is deliver the insights in an intuitive way so that non-technical people can make sense of it, they can use your segments. Fifth is use programmatic rules to track cohorts over time. Don't redo the analysis every month. And then finally, deliver a dashboard with the ongoing classification so that people can track the composition of the user base over time, and they can track how people are transitioning from one state to the other over time. And with that, we can turn it to questions.
Great, Ruben. Thank you very much. So you have, if you look at your dashboard, you have a section is called questions. So some of them have already start asking some questions. So can you say it?
I see questions, but I do not see the question themselves.
If you scroll down all the way, otherwise I can go ahead and read you like.
Yeah, I'm sorry, I do not see, I see the section called questions, but I do not see questions in there.
Okay. So here the question from Mario Samalo, he asked about question regarding k-means. How does it deal with outliers? Wouldn't outliers shift the mean and make it inaccurate?
So that's a great question. And I think that goes back to the log transform thing. You are correct that, in fact, there's a fair amount of data cleaning that needs to happen in order to have a fairly homogeneous distribution across every dimension. So one step that I mentioned was the log transform. So the log transform will take care of, like the least extreme outliers, because if you have, like, if we go back to the example of like editing, if you have people who edit 100, 150, and 200, really once you log transform those things, they will look very much close to each other, and so they won't skew the distribution as much, and they won't skew the k-means as much. At the same time, I think there is it's reasonable to exclude really extreme outliers, and so typically what I would do is I would compute the 99th percentile or sometimes the 98th percentile, and if it's like really outrageous, I will exclude anyone above the 99th percentile.
Great. So the next question is regarding also concerning log transform. Question is, instead of log transform, can we use standardization or min-max normalization?
Sorry, what was the first normalization?
So instead of log transform, can we use externalization or min-max normalization?
Externalization?
Standardization.
Oh, standardization.
Yeah.
I'm not sure what that refers to exactly. Different people might have like different views on it, but normalization basically normalize things by the mean will not solve the problem of the exponential distribution. It will not solve the problem that the difference between 101 and 102 photo edited is completely different from going from 1 to 2 photo edited. So in fact, k-means automatically does normalization for you, so you don't have to worry about it. But in this case, I think what we're talking about is the fact that there are behaviors that are very much grouped at the bottom, of the scale, or the lower end of the scale, and very much scattered at the upper end of the scale.
Okay. So another question says, "Hi Ruben, clean and nice presentation." And one question: how do you implement an uncategorized label to the model, or are those simply not yet classified clients?
I'm not sure I understand what labels means here in this context. Can we get clarification?
Yeah, so let's hope that she replies to us. One more question. So yeah, guys, we will share slides with you after the end the video, after this session. So one more question. So after the segmentation is done, have you tried to correlate the cluster with other metrics?
Yes, I've correlated those clusters or those segments with monetization, sometimes called, also, we can look at ARPU, average revenue per user, and there is some correlation between the two. But again, the goal of the segmentation is not to predict spend or to predict anything. It's just to organize our users into segments that make sense given their behavior on the app.
All right. So last question. I know you guys, you're asking a lot of questions, but time's up. So this question is, can you talk more about why you wouldn't use demographics in your segmentation analysis? So my instinct is that those variables would enhance the segmentation. Is there a way to instead weight the demos to eliminate bias?
Yeah, I mean, that's a good question and a little bit of a tricky question. I think we can use we can use like basic demographics like gender, or perhaps like if we had like 2 or 3 world regions, or if we had like 2 to 3 age group, that could be useful. But there are problems with that. One of the problems is if some of the usage is highly correlated with being a certain age or being in a certain age group, then it might be that you're seeing mostly the result of the segmentation from the age group and not from the behavior itself. Another very simple problem is like the more demographics you throw in, the more segments you end up with, and I'm not sure that what if you had like super users across all different genders and age group and geographies. Now you either have to create different model segmentation for each gender and age group and geographies, or you will end up not seeing the right segmentation, because you might see that, okay, super users are concentrated in the US on the female, and so your segment might look like the super users are only female based in the US, where in fact it is a behavior that cut across both genders and all different geographies. So I think what is a more interesting question to ask is, once we have those segments defined, super users, casual, etc., then we can look at the demographics to understand what's the breakdown, and see if super users have a different gender breakdown from casual user, or or different age group, and that will give us some more insights rather than injecting those demographics into the segmentation itself, which then becomes a little muddy.
Okay, Ruben, so there are a few more questions, but we're gonna take one more, okay?
Sure.
So you mentioned that you programmatically code the results of the segmentation to avoid redoing the segmentation every month. How often do you retest the segmentation?
Yeah, it's a great question. Ideally, you'd want to retest it every 6 months or every year. So not too often, because you want those dashboards to be somewhat stable, and you want a definition to be stable. And when you socialize those definitions, you want people to understand what they mean, and you don't want to change the definition all the time, otherwise you lose people's attention. But at the same time, I think it's important to redo it and retest your segmentation every 6 to 12 months, because your product might evolve, your audience might evolve, and behaviors will evolve over time, and you want to be able to catch that also. So it's a little bit of an art, but you have to balance you have to balance being able to socialize your results and having a stable dashboard with being able to be close and accurate with the data.
One more interesting question, Ruben, for you. How
Sure.
can you solve for the problem of unequal cluster sizes or non-spherical clusters when applying k-means?
So the first one was different
Unequal cluster sizes.
class sizes, right?
Cluster sizes.
Cluster sizes.
Yeah. So on the second question, I don't try to solve for that. I'm using like a very basic k-means algorithm. The log transform will obviously transform the dimensions, so it will not be exactly circles around the center. So it will be already like an oval because of the log transform. But beyond that, I'm not trying to do more fancy math. And in general, this is more of my bias. I'm generally biased against like fancy models and fancy math, and I prefer explainability and like having the right inputs. On the first question, I think this goes back to choosing the right clusters and the right dimension. And this is something that I omit in, I think it was slide number, yeah, that slide. I didn't talk about the size, but obviously if you end up with two clusters that represent 90% of your users and 4 clusters that are each like 2%, then there's a problem. There's a problem because they're not really representative of anything, and you don't want to be like splitting hairs and having segments that have only 1% of users. I think it's okay to have one segment that have 1, 2, 3% of users if that segment is like super high users with like crazy high usage. But if you find yourself having 2 or 3 of those clusters, then there's a problem. Either you're not using the right inputs or using too many centers. And so that's when you do the iteration in order to find basically the clusters that that make sense, that you'll be able to explain to your CEO. That's how I see it.
Hi, Ruben, it's Seamus. I'm back. I'm going to get in on the action here and ask you a few questions as well. Actually, I'm just going to read out some more as well. Another interesting question here, because there's quite a few popping up, but do you recommend standardizing all features, such as like computing a z-score in addition to log transform?
No. If you use k-means, k-means will automatically do the normalization of features.
Another question, is there a default omnibus clustering dimension reduction technique that's quite good for most use cases? Like k-means or principal component analysis, PCA or NMF, etc. I think you might have partially answered that in previous questions.
Yeah, I think the most popular one is probably, or the most basic and popular one is probably k-means, because really this is about creating clusters around like a center, and they are as differentiated as possible. PCA is slightly different. PCA is more around identifying like the main vectors of differentiation, but in my limited experience, and PCA is both more complicated and not as useful, I think, in terms of defining clear segments and explaining who is in that segment and how much behavior and usage they have in that segment. You don't really get that from PCA.
Another one interested in this context, is it necessarily true that user segmentation has to be only behavior-based data? I know you've talked a lot about behavior-based data. And I guess I'm sure the answer is true, but some examples would be good. But what are the interactions beyond demographic info and behaviors? Are there other things
Yeah.
that we look at?
So user segmentation, as we discussed at the beginning of the presentation, absolutely does not need to be based solely on behaviors. I think here I'm illustrating a behavior-based model because I think that's something that's very useful, and that's something where data, like quantitative methods, are particularly well suited. But obviously, you can also run a survey of your users or collect demographics information and try building like different personas or different type of users based on their own identities or their own like demographics. In general, I prefer to like segregate those dimensions. So there's like usage on the one hand, there's descriptors of people, demographics, etc. on the other hand, and I like to keep them separate when using segmentation.
Another question here. How much pre-processing or feature engineering techniques beside log transforms have you used in real-world solutions rather? So I guess the feature engineering technique questions of that is interesting.
Yeah. So this goes back to that step one of choosing the right inputs. So for this particular problem, really, there is one dimension which is choosing the right. So one piece of it which is choosing the right inputs or the right dimensions. In general, I do not try to build composite inputs, so I don't try to, bring two inputs together and form like a third one. I try to stay as close as possible to the raw data. But cleaning that data is obviously important. We mentioned log transform, we mentioned removing outliers. Feature engineering is to me is about like getting the right inputs. So it's always going to be a combination of data exploration and having intuition around the product itself and what might matter, and then looking at the data and making sure we remove outliers, or making sure that that data is sufficiently differentiated that we can use it to describe something else.
Next question. If we have already roughly known pre-existing segments but can't identify them 100% exactly, should we use pre-segmented input data?
Well, I think I think it's great if you are at a company or work in an organization where there are already some segments that are being defined. That's like a great start. Then rather than using that as an input in the model, what I would do is like I would create like a separate model based on behavioral data, or it can be like a model based on demographics or descriptors of people, and then compare how the segments how the segments look like between the different methods. I would not at first try to blend everything into one model. I would try to build the different models based on their own unbiased data, then compare them, and maybe at some point merge the different models together.
One of our attendees, Faye, had a question on slide 10. Can you explain a bit more, how do you transfer the left table to the right table?
Yes. So it's not a it's not a direct transformation. By the way, I obscured the dimension on the left table. So one dimension might have been like number of edits, one might be number of published, one might be like number of visits to the feed, but there were like a lot more of those. The table to the left, which is a standard output of k-means in R, just gives you the centers of the different dimensions. The centers are, because we've done log transform, it's also expressed as a logarithm, and so if you were to publish that, it wouldn't mean anything, because you'd have to transform it back to actual number of edits and publish for once, and second, because the centers are not super useful here, again, because of the log transform. We discussed it a little bit earlier, but like essentially when you do a log transform, it changes the cluster from like a circle around the center to like an oval that is deformed towards, that is extended towards the right hand side. So there you can get the underlying data from the classification, see who's classified where, and then simply get like the 10th and the 90th percentile for each dimension for each cluster, and from that you get the table to the right.
Great answers, by the way, Ruben. Next question is on everyone's favorite topic, I guess, outliers from Erez. So instead of excluding outliers, as you mentioned, why not moderate the outliers into 0.99 percentile, for example? Aren't they an important part of the population as opposed to excluding them?
Oh,
is there a way to, I guess, is there a way to include outliers, I guess, is what Erez is asking.
Well, I suppose you can run a first run of k-means with the outliers and see whether they all cluster into one cluster, basically. But in most cases, they don't. In most cases, they just like really randomly assign to different clusters, and they end up skewing your different clusters. And when it does that, that's when you know you probably need to exclude them. I don't have like, I know it's not a very good answer here, but it's more like if you see that you can run with the outliers, and if you see that they are actually having a big impact on your clusters, then it probably means that you should exclude them.
Okay, just time for a few more questions here. We've got a long list of questions. That's great. You guys have been a very active audience. This is from James. Can we use both continuous and binary variables for segmentation? Or should factor analysis be used so the factors can be used for segmentation?
Yeah, absolutely. We can use both. Yeah, both like binary and continuous data.
From Elisa, after the segmentation is done, have you tried to correlate the cluster with other metrics?
Yeah, I think there's like a similar questions earlier, and the answer is yes. I compared the clusters with, or at least I tried to correlate the clusters with the average revenue per user, and so there was some correlation there, which was interesting. But the goal was not necessarily to predict anything. Otherwise, we would have used predictive methods. It was more like to be able to describe how people are using the app, who is most engaged, and how people transition from one state to the next.
Nicholas had this question. Why not use classification models like random forests with clusters as the target instead of hard coding the clusters? Does that make sense, Ruben?
Yeah, so I'm not sure how I would do that, because random forest is typically a supervised learning method. You have to have an objective function in order to regress against. So you might regress against conversion or revenue, or stick around or churn. But here in this in this analysis, it's completely unsupervised. It's basically taking the data on its own and saying, can I see different trends within our user base just on their own, without trying to correlate with anything else, without trying to predict anything else. So it is unsupervised learning, and typically we don't use random forest for that.
Got it. Another question from Fee. Have you ever considered deep learning for segmentation?
No. I think one of the important piece of segmentation here is to be able to understand what the algorithm is doing, and to be able to explain how we came up with different segments, and being able to like find like the boundaries of the segments. I feel that deep learning would be sort of like a black box. I don't even know what would. I mean, I suppose I suppose deep learning does do that to some extent. So I shouldn't say that. It does. Deep learning would be able to identify patterns and clusters. I just don't know how I would be able to explain the output. And I also think that it is a vastly overcomplicated method for something fairly simple here.
Yeah, actually, when we ran our last conference in San Francisco, a lot of speakers kind of hit in the same theme that one thing practicing data scientists and others need to remember is that deep learning is a bit of a black box, and the need to explain your models is very important. And just saying we're applying deep learning techniques on it sometimes doesn't quite cut it. But that was a good question to explain in context. Pretty much our last question here is from Jen. Does segmentation require features to be octagonal to each other? In other words, if many features have high covariance, would it affect the segmentation results?
Yeah, I mean, yeah, we talked about it earlier, but it doesn't require the features to be absolutely orthogonal. But the more, the less covariance there is between features, the more useful they are in building the models, and the better the segmentation is. I think you want to avoid a situation where you are segmenting, along 10 different dimensions that are all like very highly correlated with each other, because then you end up basically fitting to noise, and you don't want that. Instead, you want to segment along dimensions that are somewhat orthogonal to each other in order to really differentiate people across the landscape. And this goes back to like kind of the textbook example that I had on slide 5. You want things to be fairly differentiated around those two axes. Otherwise, yeah, there's not much information to be gained by adding more and more axes.
Hey, Ruben, thank you so much for that webinar. It was actually very insightful. I really got a lot out of that myself, and I'm sure our audience is as well. And good attendance, by the way. I think we had over 150 people at one point. So I do apologize to all of you whose questions we did not get to answer. There's quite a lot in there. We will make the recording available if you want to review it again. However, I think we'll just edit out the initial technical difficulties we had. So clean it up a little bit. And then on the slides, Ruben, a number of people asked about the slides. Do you want to make those available via SlideShare or send them to us? Because we're sending out an email to the registrants after this. So however you want to make those slides available, that would be very, very useful.
Absolutely.
Great, and thanks once again. I hope you enjoyed that, Ruben. That was really good. And I think by the amount of questions our audience asked, that was very well received.
Thank you. It was a pleasure.
Wonderful. And to all our audience, thank you so much again. Keep an eye on our webinar calendar. We're going to be doing 1 or 2 of these a month. And as I said, if you're looking for more excellent speakers like Ruben, please check out opendatascience.com and our blog site, and follow us on Twitter and all that good stuff. And we'll be sure to share lots of great content with you. Once again, thank you so much for joining us, and bye now.